Hello, this is Professor Poyser, and I'm going to show you Part B of Chapter 5's question number 37. And this again is on page 212. I previously recorded Part A's result. In fact, speaking of which, it's right here. I showed you this table and this information at the end of Part A's video. And for you MAT 237 probability and statistics students, my online students, again, this corresponds to your question number 8. This is Part B of homework number 5. Okay, homework number 5, question number 8, Part B. So at the end of Part A, I showed you that the expected value of the mean, the average of the two sizes of dishwasher soap that was selected, turned out to be 44.5. Again, this is for the example out of the textbook. Your numbers might be different on WebAssign. Okay, so what we're going to do for Part B is that they're asking us to determine the sampling distribution of the sample variance, that is S squared, and they want us to calculate the expected value of S squared. Well, just real quickly here, notice this little note here I put page 33 is something that you ought to go take a look at, page 33, because that's where it talks about population variance, rather, not sample variance, but population variance. And that formula is simply x minus mu, or x minus the mean, quantity squared, and it's really technically divided by n after we sum them all up, but I'll get to that in just a moment. Okay, so what we have then is we're going to work out a simple little formula, this little formula right here. We're going to work that out for each of these cases that you see that we worked out from Part A. So, for example, I'm going to work out 25, my x value, minus its mean, 25. Well, that's kind of an easy one, right? 25 minus 25 is just 0, and 0 squared is still 0. So, and we're going to do the same thing for x sub 2. Not very exciting for this very first case of 25 minus 25 and 25 minus 25. But I do want to show you, though, that this is really what I'm doing here for each of these cases. So I'm going to do 25 minus 25, right? And then I'm going to take that quantity and I'm going to square it, which is simply still 0. I will do that for not only for x sub 1, but I'll also do it for x sub 2. X sub 2 was also 25, and that x bar for both of these cases was 25. So it's not very exciting. It's not very informative for our very first case. But let's take a look. Let's take a look at this second case. The second case is if the first customer chooses 25 and the second customer chooses 40. Can you see that there? First customer chooses 25, second customer chooses 40. Well, we said earlier in Part A that the average was 32.5. So I'm going to take the difference of both of these. Ready? I'm going to take the difference 25 minus 32.5 squared, and I'm going to do the same thing with 40. I'm going to take 40 minus 32.5 quantity squared. So here it goes. The first one is, let's see, here it is. First one is 25 minus its mean, 32.5, and that value comes out to be a negative 7.5. But don't worry, we're going to square that. It's going to become positive. Right? It's going to become positive. And let me just scoot this up so I can get some more space. I'm going to do the same thing for its buddy over here, which was 40 minus 32.5, which is the positive version, 7.5, but we're just going to square it. So in each case, when I square these, I get 56.25. Well, I hope you see that since there were two of them, right, since there were two of them for this second case, then all I'm going to simply do is add them up. Right, so I'm just going to add these two values up and come up with 112.5. Same thing here. If I just simply added these guys up at the top, you'd see that their value is simply 0. Nothing really exciting there. You just see that that works out. Okay, so you can add those up and you come up with 0. If I add these two up, I come up with 112. Let me show you one more example here. Take a look at this third case. All right. Yeah, this third case here, guys, is 25. So I can get the lighting right. 25 minus its mean, which is 45, and then I'm going to square that quantity. I'm also going to do 65 minus 45 and square that quantity. Watch what value shows up, okay? So let's do that here real quick. I'm going to do 25 minus its mean, which was 45, and you can see that that comes out to be negative 20. I'll square that. I'm also going to do 65 minus 45, its mean, which came out to be positive 20 squared. So in each of these cases, when I square them, that comes out to be a positive 400. And then what am I going to do with that 400 in each of those cases? I'm simply going to add them up and get 800. So I'm showing you all of that because now what we're going to do is we're going to create a little table of our sample, or rather our population variance. And that table looks like this. So I can get this to work here. I don't have a whole lot of space in my office. Okay, so here's what I've got then. I've got a little table, and I hope you can see where this table is being created from. Remember, if we added up some values, right? If we added up some values, we ended up with 0 for the first case. The second case, we ended up with 112.5. And for our third case that I worked on, we had 800. Well, if you work out each and every single one of those cases, you'll see that 312.5 shows up, as well as 0 shows up again for the case of 40 and 40, as well as for 65 and 65. So my point in all of this is simply saying, listen, from this table that I showed you in part A, all right, this case right here is going to give us a 0 for population variance. Right? What is that probability? 0.04. This case is going to give us 0, 40, 40, and 40. What is its probability? 0.25. And this case is going to give us 0. 65 minus 65 is 0. You add either one of those up and you get the same value. So its probability is 0.09. If you add this 0.04 to this 0.25 to that 0.09, you will get a total probability of that population variance of 0.38. Okay, so I added all those values up. That's how I got 0 out of this. Likewise, if you add up your values, get rid of this. Likewise, if you add up your values for the second case, you'll see that 112.5, that population variance, shows up for a total of 20%. 312.5 shows up for a total of 30%, and 800 shows up for a total of 12%. Now, last but not least, and to finish off part B, we're looking for the expected value, right? This is what we're looking for. We're looking for the expected value. So expected value, guys, is simply as you saw in part A, hopefully, of the videos, right? Expected value is simply the product of, this is really jumpy, sorry. All right, it's the product of these two guys over here, right? S squared times its probability, and obviously 0 times 0.38 is simply still 0. 112.5 times 0.20 is a particular value, right? We can do all this stuff on our calculator and we come up with these values. Well, when we're all done, we're just going to add them all up, right? We're just going to simply add them all up, and we're going to come up with a sum. Whatever that sum is right here, whatever that sum, magical sum happens to be, and I'll tell you what that is for these values if you want to work them out separately, is our expected value of the population variance. All right, this is our expected value of the population variance S squared. That's what we're after. Well, you can try all these out, right? Take these these two products right here, and here we go. Right, take the product of these two numbers, 112.5 and 0.20, and put that right there. Take the product of 312.5 times 0.30, put that right there, etc., etc. And when you add up all of these values in this last column, you should end up with 212.25. That is our expected value of population variance.